So the first section that you look at is the farm and management details section. So each of these represents a drop-down box. We've got 7 different sites for Tassie. So let's pick tundridge in this example. There's 2 different variety types. There will be 3 once the tool is finished. So that'll be winter wheat and winter and spring canola. So let's pick winter canola in this case. The sowing date might be the 1st of April. Pick a planting density. There's only 2 options for canola, so that's 50 plants per square metre. Let's choose 50 plants per square metre in this case. There's 3 different irrigation options that are rain fed. The abbreviations there represent 0 obviously represents no irrigation, F represents full irrigation, and the P is partial, so IP is partial irrigation. Let's pick the second option for partial irrigation, which applies irrigation which tops the soil up essentially with 10 millimetres between zadok stage 10 and 71. Fertiliser at sowing, let's say 50 kilos per hectare. Soil type, these soils have basically been selected for the most predominant soils around a region. So obviously soil type is highly heterogeneous, not only within a region but also within paddocks. So you just have to use probably the best available soil at the moment. Alternatively, you can contrast with soil types at different sites, but beware that the climate will be different as well. So, but overall, I guess the whole purpose of this tool is to compare what-if scenarios. So, what happens if I compare different fertiliser types to different sowing dates to different initial soil water at sowing and so on. So let's say it's a clay loam in this case. Initial soil nitrogen, unless you've got a soil test, you'll have to take a guess. That has quite a big impact on the results, but I encourage you to just explore the variation between results. Let's say it's medium. Soil water, let's say it's a dry sowing. And now we have to put in a target yield, let's say 6 tonnes per hectare, and an estimated flowering date. And here I've put in the 20th of September, but obviously that will depend on the year and your site. Then you hit update results and graph, and the model will come up with these long-term simulated values. So it's saying if you've wanted a predicted yield, a target yield of 6 tonne per hectare, you're actually going to only get 3.1 tonne per hectare given these configuration conditions down here, and you've got an estimated flowering date of the 23rd of September, so the guess of the 20th of September is about right. Then we go down here and we've got these 2 scenarios. So the first one is essentially what happens, what's the biomass, and what happens if we lock up the paddock today, that is remove all the livestock from your crop today, versus scenario 2, which is delaying the livestock removal until some future date, and you have to put in the stocking rate as well as the estimated residual biomass. So let's say today's date is I don't know, July 16, and the current residual biomass is let's say 1.5 tonne per hectare. If you don't know, you can hit this button here, which provides a bunch of images. So we've got a bunch of different measured dry matter for winter wheat, spring wheat, and winter and spring canola. Okay, so let's say that we're going to have very little spring canola at this stage. So let's say it's 0.3 tonne per hectare. And then we go into the future. This is where we have to do a little bit of hypothesising. So we have, you have to say what your estimated residual biomass would be. Now that's got to be a guess, obviously, but you've probably got an approximation of the date that you're going to remove them. So let's say the 15th of August, and let's say the estimated residual biomass, let's say 1 tonne. So it's gone up from 0.3 to 1 tonne. You can't have estimated residual biomass and stocking rate at the same time, so let's take that stocking rate out just for clarity purposes. And down here, when you hit update results and graph again, it shows you the predicted potential yield for scenario 1 and for scenario 2. So they're about the same really. So scenario 1 is about 1.8 tonnes of grain per hectare, and scenario 2 is about the same. Then it also gives you probability, so and as well as differences between your target and projected yield. So your projected yield, remember, is the yield that you put in up here. And then it's got the results over here on the graph, which are basically displayed in terms of total above ground biomass. It shows the target anthesis biomass which you initially put in, which is based on that target yield that you put in up there, and then it shows the two regrowth lines. Now you can see that the red line is the alternative lockup is the red line, and the current lockup is the blue line. Here they're essentially the same, so you're going to get pretty much the same result, but just for illustration purposes I might fiddle the numbers a bit so that they come out a bit different. And essentially this is the whole purpose of developing a decision support tool, so you can play with the numbers and see what sort of alternative outcomes you get. So if I just change this number here to I don't know, let's say 3 tonne per hectare, because it's a time in the future. You can see that the red line now has jumped up a lot, and you're going to have a lot more biomass left at the end. And so when you go up here and you look at the economic analysis of additional grazing, I've got no idea what the value of canola might be per tonne at the moment. So this could be drastically wrong, but let's say $350 a tonne. Now you put in your livestock enterprise. Let's just say it's a ewe flock of adults, and then you have to put in the dollars per head per day. If you don't know and you can't calculate it, these values are pre-populated anyway. So if you actually put in prime lambs, it says 45 cents per head per day, and so on. So let's go back to the adult ewes, hit update results and graph. And when it has a non-zero value for grain loss there, that means you've got a bug in your initial simulation. So you must have some sort of error with your economic calculation. So in that case, you need to go back and hit clear and just put in another value here and then actually see what happens. But I'm not going to do that in this case. I'm just going to continue with the demonstration and show you what happens. Essentially, you can see what would happen anyway, and which would probably result in the highest grain yield. It's going to be the second. It's going to be delaying the lockup date to the 15th of August with an estimated residual biomass of 3 tonne per hectare. So let's go back here and let's just take out this estimated residual biomass. Let's say we don't know what that is, but we do know what the stocking rate is. Let's say it's going to be 10 dry sheep equivalents per hectare, and it's going to be a prime lamb enterprise. So here we hit update results and graph. Now we can see that the red line is actually below the blue line, so grazing at 10 DC per hectare until the 15th of August is below it, and these dotted regions actually display the error range. And so you can see that although the blue line is slightly better, it still overlaps in the potential error there. And so when you go back up here to the economic value, you can see that indeed that was a bug in my previous simulation, but this one has turned out right because I've got the values right. So the value of additional grazing is $99 per hectare, whereas the value of the grain loss is a little bit more, so it's $125. That's assuming the grain price is $350 a tonne, and we're getting 45 cents per head per day. So the grain loss would be about $26 per hectare in that case. So that's basically what you do. You just go backwards and forwards, keep changing the dates and exploring the range of possible outcomes that you could get with the tool. The other thing that you can do, in that it takes quite a while to set up the simulation, and once you're happy with an arrangement of most of these options, you can hit save configuration. Then you put the name in. Let's say Tunbridge example. And then you hit save configuration, and they actually go up here. So here's one I did previously. This is the sassafras example, and then when you hit apply configuration, all the pre-existing data comes up. So you can see that we've got quite a lot different outcomes from what I put in the previous example, and we've got a different enterprise there. So you can just go back and play with the initial values that you put in originally.